Hi friends, in this video we are going to discuss about previous gate questions in our DC missions. Right? A DC shunt motor is running at 1200 RPM. When excited with 200 volts, this is my supply voltage and this is the speed. I am neglecting losses and saturation. Losses neglected as well as saturation also not considered. The speed of the motor, we have to find out the speed. The speed of the motor when connected to 175 volts of DC supply. So simply they given that at 200 volts the speed is 1200 RPM. At 175 volts, what is the speed of the motor? So generally people doing directly proportional. If you doing like this, you can get some other answer. It may be 1050 answer you can get. For 200 volts, 1200 RPM. For 175 volts, you can get 1050 RPM. This is 100% wrong answer, right? So how we can do? Generally in DC shunt motor, right? In DC shunt motor, in generally the speed is directly proportional to EB by 5. Nothing but N2 by N1 is equals to EB2 by EB1 into phi1 by phi2 because inverse proportional, right? And he said that the voltage reduced to 175 volts. When voltage reduced to 175 volts, corresponding back EMF also reduces. Corresponding flux also reduces. Yes or no? The corresponding back EMF reduces and corresponding flux also reduces in equal proportional. Because in shunt motor, actually the current in this shunt field ISH is equals to V by RSH. ISH is directly proportional to V. When V reduces, ISH also reduces. When ISH reduces, flux also reduces. ISH is equal to V by RSH. When V reduces, ISH reduces. When ISH reduces, flux also reduces. So, when voltage reduces, the back EMF reduces as well as our flux also reduces. In equal proportional. Then tell me what happened. When these two are reduces in equal proportional, the N2 by N1 is equals to constant. Nothing but the N1 is exactly equals to N2 or N2 is directly equals to N1. No doubt at all, the DC shunt motor is a constant speed motor, right? Yes or no? DC shunt motor is a constant speed motor. In DC shunt motor, if you changed your supply voltage, there is no changes in speed. This is very important and repeated question. In DC shunt motor, even though if you change the supply voltage, there is no changes in speed because this is a constant speed motor, and because here EB reduces and flux also reduces in proportionally, both gets cancelled out all. So N2 is exactly equals to N1. N2 is exactly equals to N1. So this is our answer. What is our answer? Is also 1200. Is the same 1200. So next question, a compensating winding in a DC machine. Tell me sir, generally where we are placing the compensating winding? Generally the compensating winding placed under pole shoes. Yes or no? So generally it is located on pole shoes to avoid the flashover at the commutator surface. Why? Because we are using compensating winding to avoid the sparkings, right? Sparkings nothing but the flashovers. to avoid the flashovers at the commutator surface. So generally here we have 4 options. In that the third option is locating on pole shoes to avoid the flashover at the commutator surface. Nothing but generally it is placing under pole shoes. Generally it is placing under pole shoes. Placing under pole shoes to avoid the cross magnetization effect, or to avoid the sparking commutation, or to avoid the flashover at the commutator surface is the 100% correct answer. Right? What is the next question? At 240 volts, the given supply voltage. At 240 volts, DC series motor takes 40 amperes. What is 40 amperes? It is the armature current or line current. Both are same for motor, series motor. When giving its rated output at 1500 RPM. Rated output at 1500 RPM. Its resistance is 0.3 ohms. Resistance nothing but this is armature resistance plus series field winding resistance. Complete resistance they given 0.3 ohms. The value of resistance we must be added. Nothing but this is extra resistance required. Extra resistance required to obtain the rated torque. Extra resistance should be obtain the rated torque. Rated torque. Some missing is there. Rated torque at 1000 RPM. Rated torque at 1000 RPM. What they given? At 240 volts, DC series motor takes 40 amperes. When giving its rated output at 1500 speed, its resistance is 0.3 ohms. The value of resistance, extra resistance, must be added to obtain the rated torque at 1000 RPM. So, actually the rotor is rotating at 1500. Now I want to control my rotor speed up to 1000 RPM. Now I want to control my rotor speed up to 1000 RPM by armature resistance method. Then what is the formula? What is the formula? Actually, the N is directly proportional to EB. Nothing but N2 by N1 is equals to EB2 by EB1. What is EB2? Tell me, sir, what is first EB1? EB1 is equals to V minus IARA. But EB2 is equals to V minus IA into, for example, this is RA plus RAC actually. For example, I am taking R. They given 0.3, right? RA plus RAC is taken as 0.3. Now here R plus extra resistance added RE. Let's substitute here. N2 they given 1000. N1 they given 1500. N2 1000 and N1 they given 1500 is equals to EB2 V minus 240 minus IA into R plus RE divided by, tell me sir, EB1 240 minus IA into R. This is the equation. That's it. N2 by N1 is equal to EB2 by EB1. EB1 is equals to V minus IA into R. EB2 nothing but second one. When extra resistance added. When extra resistance added RE. So N2 by N1 is equals to EB2 by EB1. If you calculate this value, for example, 500 2s are 500 3s are. So 2 by 3 that is equals to 240 minus 40 into 0.3 plus RE extra resistance divided by 240 minus 40 into 0.3 nothing but 12. 240 minus 12, 228. 228. Right? If you calculate this value and find the RE is exactly equals to, you can get 1.9 ohms. You can get 1.9 ohms. How we can get here? What is the answer here? In our options, which are the following is correct answer? Option D, 1.9 ohms. Just calculate, just take the cross multiplication. If you do the cross multiplication, if you solve this, you can get the extra resistance RE. Extra resistance RE is equals to 1.9 ohms. Is very important question, repeated in many competitive exams. Okay, let's see the question. The permanent magnet DC commutator motor has no load speed of 600 rpm. Okay, the given no load speed, for example, N1 is 6000 rpm. 6000 rpm. Next, when connected to 120 volts DC supply, they connected to 120 volts DC supply. So they given V is equals to 120 volts. Generally, what is the formula? EB is equals to V minus IARA. But this is at no load, right? No load, nothing but IA is equals to 0, right? If IA 0, this value 0, right? So, EB1 is equals to V. What is V? What is V? 120 volts. They given V. Okay. So, generally, we know that N2 by N1 is equals to EB2 by EB1. Right? I want EB2. EB2 is equals to EB1 into N2 by N2 by N1. N2 by N1. Now tell me what is EB2 value? EB2 is equals to 0, 0 gets cancelled. 12 ones are 12 5s are. So EB2 is equals to N2 by 50. EB2 is equals to N2 by 50. This is my EB2. And let's see here what they given. They given armature resistance of 2.5 ohms and other losses neglected. Armature resistance given, other losses neglected. The speed of the motor, nothing but N2. We have to find out N2. The speed of the motor with supply voltage of 60 volts. So generally, EB2 is equals to V minus IARA, nothing but IA2RA. Here V2, they given V2 60 minus IA2 into RA. This is my EB2. This is my EB2. Can you find IA2 from this? IA2 is equals to 60 minus EB2 by 2.5. This is my IA2. Yeah, I got IA2. Now, they given another one, supply voltage, a torque of 0.5 Newton meters. They given torque also, right? How we can solve now? For that solution, they given one hint here. The motor having the 0.5 Newton meters of torque. We have to use this one. How? Generally, the P is equals to T into omega or omega into T. P nothing but EB into IA is equals to 2 pi N2 by 60 into T. T they given 0.5 Newton meters. 0.5 Newton meters. Right? Now tell me what is EB2? EB2 is EB2 only. Next, what is IA? IA2 is equals to 60 minus EB2 divided by 2.5 is equals to 2 pi by 60 into N2 into 0.5. N2 into 0.5. Right? Actually, this is. Can you tell me what is N2? N2 is equals to 50 into EB2, right? N2 is equals to 50 into EB2. For example, in terms of N2, just write 50 into EB2 into 0.5. See, somewhat large equation you got. Large equation, of course, you got. So, here EB2 is there. Just multiply it. and here also EB2 is there. Just multiply it and tell me what is answer actually. If you multiply this, what is answer actually? 60 into EB2 minus EB2 square, that is equals to 2.5 into 0.5 into 50 into 2 pi divided by 60 into EB2, right? So if you convert this in here, you got one quadratic equation, like a quadratic equation. If you solve this quadratic equation, if you solve this EB is there. If you solve this EB, you can get EB2 53.455 volts. You can get 53.455 volts. If you solve this equation, quadratic equation, in your calculator you can solve it. If you solve this, you can get 53.455 volts. 53.455 volts. Then tell me what is N2 now. N2 is equals to 50 into EB3. 50 into EB3. Then tell me what is answer. N2 is equals to you can get 2672.75 RPM. You can get N2 value. If you multiply these two, you can get 2672.75 RPM you can get. Tell me what is the answer now? Which of the following is correct answer? Yeah, mostly this is correct answer because nearer value. So actually what we done here, let's see here once. First they given N1 and supply voltage, and he said that no load, that's why IA 0. If IA 0, EB1 is equal to 120 volts. Thereafter I find that EB2 from this equation. Thereafter from the question I find that EB2, from that IA2, and they given the torque equation, torque 0.5. That's why P is equals to omega into T. From that, I build up a quadratic equation in terms of EB. And if you solve this quadratic equation, you can get EB value 53.455 volts. If EB value is 53.45 volts, then N2 find out. Actually, find the speed of the motor. N2 is equals to EB2 into 50, then you can get 2672.75 RPM, which is nearer answer 2673 RPM. 2673 RPM. Yeah, listen carefully. Somewhat typical, very different problem. Okay, sir, next question. An electric motor with constant power. Electric motor with constant power output or constant power will have the torque speed characteristics. What he said? Constant power. And what are the torque speed characteristics? Straight line passing through the origin, parabola, circle about the origin, rectangular hyperbola. Tell me, sir, what is the formula for power, speed and torque? Power P is equals to speed into torque. Constant power, they said that the power is constant. If the power is constant, if speed increases, what is that? If torque increases, speed decreases. If speed increases, torque should be decreased. If speed increases, torque should be decreased. Nothing but if one increases, one decreases. If one decreases, one increases. Nothing but inversely proportional, right? So the torque is inversely proportional to speed. The torque is inversely proportional to speed. If the power is constant, if speed increases, then torque decreases. If power is constant, if speed increases, then torque decreases. Nothing but this is rectangular hyperbola. Generally, we know if both are directly proportional, straight line, straight line. If both are inversely proportional, rectangular hyperbola. If straight line, directly proportional. If rectangular hyperbola, inversely proportional. For example, if torque is directly proportional to n square, parabola. We know these all. So here, generally inversely proportional, that's why rectangular hyperbola is correct answer. If any is there the condition directly proportional, then first one is correct answer. If directly proportional to square, then second one is correct answer. Actually, but now here the torque is inversely proportional to speed. That's why option D is the correct answer in my question. Right? Next question. 200 volts, 2000 RPM, 10 amperes. Separately excited DC motor has armature resistance of 2 ohms. Rated voltage is applied to both armature and field winding of the motor. If armature draws 5 amperes from the source, the torque developed by the motor. So torque T is equals to P by omega. P is nothing but EB into IA by 2 pi n by 60. So torque T is equals to, first find out EB. EB is equals to V minus IA into RA. Nothing but 180 volts. If you substitute 180 into 10 amperes divided by 2 pi 2000 divided by 60. If you calculate this answer, you can get 8.598 Newton meters. 8.598 Newton meters. But actually, this is not the correct answer. Why? Actually, they want the torque at 5 amperes. They want the torque at 5 amperes, but I calculated at 10 amperes. We know torque is directly proportional to IA. T2 by T1 is equals to IA2 by IA1. So T2 is equals to T1 into IA2. What is IA2? 5 amperes. IA1 10 amperes. For 10 amperes, this is the value. For 5 amperes, what is the value? Calculate once or twice. If you calculate this, you can get 4.299 Newton meters. 4.299 Newton meters. What I done? Torque T is equal to P by omega, EB into IA. EB is 180 volts. IA is the 10 amperes. Actually, I calculated the torque, but I want torque at 5 amperes. Torque directly proportional to IA. T2 by T1 is equals to IA2 by IA1. T2 is equals to T1 into IA2 by IA1. Then you can get 4.299 Newton meters. The torque developed by the motor at this current is 4.3 Newton meters. 4.3 Newton meters is 100% correct answer. A DC series motor fed from the rated supply voltage is overloaded and its magnetic circuit is saturated. Overloaded and its magnetic circuit is saturated. The torque speed characteristics of a motor will be approximately represented by which curve? The torque speed characteristics they are asking. Torque and speed characteristics. Generally, the torque is directly proportional to IA square. Torque is directly proportional to IA square for DC series motor. So, actually, when the magnetic circuit is saturated, torque directly proportional to IA. Because in generally torque directly proportional to phi into IA. Before saturation, IA directly proportional to flux. After saturation, flux is constant. Because of saturation, flux is constant. But before saturation, phi is directly proportional to Ia. Ia into Ia square. But when flux is constant, torque directly proportional to Ia. So mostly the Ia directly proportional to N, directly proportional to T. Directly proportional, nothing but a linear curve. Directly proportional, nothing but a linear curve. Yes or no? Directly proportional, nothing but linear. Inversely proportional, nothing but rectangular hyperbola. Square, nothing but parabola. I already given you just now. Yes or no? I given you, right? So directly proportional, that's why it is a linear curve. Option B is the correct answer. Option B is the correct answer. Due to saturation, linear curve is the correct answer. Right? Generally, the question to see very big, but very simple analysis, very easy question. Let's see. To conduct load test on DC shunt motor, a DC shunt motor, a DC shunt motor. For example, this is my DC shunt motor. I am conducting load test on this. Nothing but this is connected to a load. Motor connected to a load. This is my DC shunt motor connected to a load. Is coupled to a generator which is identical to the motor. Nothing but the load of the motor is my generator. Actually, it is load test, sir. Yes, I have to apply the load on the motor. That is generator they given. That is generator they given, right? Connected to a generator identical to the motor. The field of the generator is also connected to the field of the generator is also connected to the same supply source. My God, here the field also connected. Yeah, are you getting or not? The field of the generator is also connected to the same supply source. Yeah, of course. As the motor, the armature of the generator is connected to the load. What happened? The armature of the generator is connected to the load. Armature of the generator is connected to the load. Right? Armature resistance 0.02 per unit. Nothing but the armature resistance of generator, armature resistance of motor, they given 0.02 per unit. Armature reaction and mechanical losses neglected. Armature reaction and mechanical losses neglected. With rated voltage across the motor, we are giving rated voltage here. The load resistance across the generator is adjusted to obtain armature current, rated armature current in both. Nothing but what he said that here, with rated voltage across the motor, the load resistance across the generator is adjusted. This load resistance is adjusted. This load resistance is adjusted to obtain the rated armature current. To obtain the rated armature current both in motor and generator. Then find the per unit value of RL. They want this RL. Yes, they want this RL. And they said that the armature current of generator, armature current of motor is rated. Rated nothing but, sir, 1, sir. Rated nothing but. Rated nothing but 1. Now I have to calculate RL. RL, generally RL is nothing but the terminal voltage of generator by armature current of generator. The terminal voltage of generator by armature current of generator we have to find. Actually, this armature current of generator 1 they given, it is already is there. Now I have to find out VZ, the terminal voltage of generator. Terminal voltage of generator. Before that, I have to find out the output of the motor. Output of the motor is equals to input of the generator, right? So, output of motor is equals to input of generator. Output of motor is equals to input of generator. Output of motor is nothing but EB into IA is equals to EZ into IA. Yes or no? Right? EZ into IA. Tell me, what is here EB into IA? What is the EB into IA? For example, I have to find out easy. I have to find out easy. Right? Find EB. EB is equals to V minus IARA. For example, V is equals to 1. Rated voltage, right? V is equals to 1. IA 1 and RA 0.02. 1 minus 0.02 is 0.98 per unit. Rated value, that's why 1 into 0.02, 0.98. Yes, I got 0.98 into 1 is equals to EZ into 1. So tell me EZ is equals to 0.98. But for generator, EZ is equals to V plus IARA, V plus IARA, V plus IARA. EZ is equals to 0.98, that is equals to VG plus IA into RA, IA into RA. Then find VZ. VZ is equals to 0.96. 0.96. Yeah, tell me now RL is equals to 0.96 by 1. That is 0.96 per unit. 0.96 per unit. Yeah, are you okay? So very simple. They given RA, they given IAM, and they given rated voltage. Nothing but voltage is equals to 1 per unit. 1 per unit. EB is equals to V minus IARA. V is the 1 per unit, IA is the 1 per unit, and RA is the 0.02. Why 1 per unit? Rated current, rated voltage, rated nothing but 1 per unit. I calculated EB. And motor output is equals to generator input, nothing but generally I output of motor, input of generator, EB into IA and EZ into IA. Then EZ of generator. EZ is equal to V plus IARA. EZ, V, IARA, VZ 0.96. 0.96 by 1, 0.96 per unit. Yes, I got the load resistance. This is the answer, guys. Okay, next question. See, very tricky question and very important. We cover all the machines. DC machine, synchronous machine, induction machine. Let's check the options. First one, in DC machine P and Q, what are the statements? P, the statement P. Stator winding current is DC. Rotor winding current is AC. Q statement. Stator winding current is AC. Rotor winding current is DC. R. Stator winding current is AC. Rotor winding current is AC. Yes. Stator winding has salient poles and rotor has commutator. Commutator nothing but only DC machine, right? T. Rotor has salient poles and slip rings. Salient poles and slip rings. Stator is a cylindrical. U. Both stator and rotor has polyphase winding. Let's check it first. For example, D is the P. For DC machine, P is correct answer or not? Let's check it. Stator winding current is DC. Yes or no? In DC machine, generally in DC machine, the stator is a field winding and the rotor is armature winding. Generally, field winding carries DC supply, armature winding carries AC supply. So, P, the stator winding current is DC, rotor winding current is AC, is correct answer. And yes, stator has salient poles and rotor has commutator. Yeah, is correct answer. The rotor has commutator, this is correct answer only. Next, synchronous machine. Synchronous machine, stator has armature winding, rotor has field winding. This is AC, this is DC, right? Let's check it. Q. Stator winding has AC current, rotor winding has DC current. Stator has AC current, rotor has DC current. Let's check it. T. Rotor has salient pole and slip rings. And stator is cylindrical. Yeah, correct answer. Salient pole. Salient pole machine. This is also correct answer. Next, induction machine R. Where is R? The stator winding has AC current, rotor winding has, yeah, both are AC. In induction machine, this is 100% correct. Next, U. Both stator and rotor has polyphase winding. Yeah, exactly correct answer. So option A finally the correct answer. Option A finally the correct answer. The DC machine, the synchronous machine, and induction machine. Regularly in DC machine, stator having DC, rotor having AC. In synchronous machine, stator having AC and rotor having DC. In induction machine, both stator and rotor both having AC. Like that, option A is the correct answer for this question. Okay, next question. They given like that. Match the following. Yeah, field control method and armature control method. Tell me, sir, generally N is directly proportional to EB by 5. When flux control, the speed increases. Yeah, generally we know the field control method is the above rated speed control method. Above rated speed control method, right? And armature control is the below rated speed control method, because in armature control method EB reduces, speed reduces. In armature resistance control method, EB reduces, speed reduces, and in flux control methods, flux reduces and speed increases. So armature resistance control below rated speeds, and field control method above rated speeds. This is generally we know that.